The following video presents the management application demo that includes the Arrowhead test tool, consumer interface generator, and the engineering tool for legacy adapters.
Hi, I am Maro Thron from IFAG in Germany. In industrial production systems, there are information sources like sensors or process control systems. They are connected via industrial communication systems like Modbus TCP or MQTT. Legacy adapters can transfer the information from the device to the Arrowhead system. The development of these adapters is time-consuming, and thus we wanted to automate this work. Interoperable devices are based on semantic standards, which are distributed today as text documents. But machine-readable format is required for code generation, and so we developed a formal language for device interface description based on XML. XML notation isn't easy to use, and a form-based input system was required. Thus, we developed a web application which consists of two parts. With the data structure editor, it is possible to describe data structures. The equipment type interface editor allows to use these data structures for the description of concrete device types. The resulting equipment interface description is then used in a code generator to generate parts of the device firmware. Specifications of data structures are organized in repositories and libraries. Data structures can then be added in a form. Also, equipment type interface descriptions are stored in repositories. They contain data block definitions, while the block members contain a name, various communication parameters, and a data type reference. The code generator creates a zip file which contains the application service code. A single Java class has to be adapted to access the device information via the original industrial communication system. The Arrowhead core services can be started via a script. The generated code can finally be compiled and started and can then also be accessed via a web browser. Our hydraulic pump example is further used in other parts of our demonstration.
Hi, I'm Cristina from LTU. I'm going to present the consumer generator system, a system designed to solve interoperability issues in runtime via the autonomous generation of consumer interfaces. It talks with the Arrowhead core system to get the necessary information. In this case, we are going to generate a consumer interface capable to consume the service from the legacy system provider already presented. The input of the generator is the service contract description of the systems. This information is structured and presented using a description language called CDL. As you can see in the screen, the XML has all the information from the encoding, security, semantic elements in the payload, and other service contract features. The folder that is going to use for the generation is already prepared with the dependencies, and the interface instance is created in this moment. You can see the pop-up window. It has been created by the generator that is running in the background. The folder that was previously empty now is full of code, and the code is built and execute autonomously. The first method is the one that talks with the orchestrator to get the endpoint. And once the legacy system endpoint is retrieved, we can use it to consume the service. Several options has been introduced, so we can use the command line to retrieve that information from the service. As you can see, the information and the communication is successful. Finally, I'm going to show you the different classes that have been generated. The consumer main that has the method to communicate with the orchestrator and to consume the service, and the different classes that has been created to map the element and the structures for the message payload.
Hello, my name is David Ågren and I'm a systems developer at Bineret in Luleå. I will demonstrate how the test tool can be used for validating and testing interfaces by creating both providers and consumers, which can be used with services published in an Arrowhead cloud. I've prepared a project and a scenario called Demo, in which I have created two new systems that will contain the new services. I will now create a new generic service by providing a bundle, web application description language file, and an XSD file, XML schema definition. This is used as the descriptor for the service interface and data structures. I specify the generic pump block as demonstrated by Cristina and provided by Mario. I fill in the fields and register the generic service. and once the service is registered in the system, we are able to create and communicate with other generic pump block services. This can be seen as an externally provided service called Legacy System Generic Pump Block, which will soon be visible in the right-hand toolbar. In Test System 1, I create a new provider and select the generic service I just registered, assign name, and proceed. The service is started, as can be seen in the event log at the bottom, and published to the Arrowhead cloud to the right. The provider is now ready for use, externally or internally. In Test System 2, I create a new consumer following the same steps as previously. As you can see in the right-hand toolbar, both our created services and an externally provided service is now available in the service registry. I can now connect my consumer and exchange information with other general pump block services. My consumer is now connected to both my own recently created provider and an externally provided found in the Arrowhead cloud. Thank you.